While waiting, what we can do, I'm going to show you a dismantled battery. So this is a Toyota Prius battery. It has been dismantled from another vehicle. So what we have here is all electronic components, all sensors have already been removed. So even the power relay controller and the BMS, it has all been removed. Now, what you will see here is basically what we call as a battery pack. And this individual rectangular shape is what we call as a battery cell. If you can see, there's a negative and there's a positive, whereas the next rectangular shape is a negative and positive. In other words, it is a series connection. So typically in a battery pack, the construction would be a battery cell and two or three or two or more cells will make a battery pack. Sorry, will make a battery block or a battery module, and a few modules will make a battery pack. So we have the cell, we have the block or the module, and then we have the pack. All right, so this is what we call as a battery pack. Now, in what we're going to do is we're going to test the battery cells, because even though this battery has been removed, there's still voltage in the battery cell itself. So that is why it is recommended that after removing any battery, do not just leave it lying around. Even if you need to store it while waiting for parts, you need to isolate, barricade it, and have ample warning labels and warning signs to warn people of the dangers. I'm going to test the battery cell to see if the cells are working. Now, battery again is direct current, right? So what we're going to do is that we're going to put the probes onto the connecting pins, and it has to be cell by cell. So what we have is 7.40 volt DC, right? And the next cell will be a 7.39 volt DC. And then if we move it on, other cells, we have 7.4, and then we go into, we have 7.41, and we go into the end, we have 7.43. Now, the purpose of this is basically to check if there is any imbalance of the individual cell. Because if you have a cell that is below the manufacturer's standard voltage, you would know that that cell is a bad cell and it needs to be replaced. Now, how do you know the voltage of each individual cell? For this, we have tested and it shows 7.4 on average. Now, the individual voltage on each cell varies between each model and each make. So it is best that before you start work on a high voltage vehicle, you are equipped with the manufacturer's specification, where you will know where is the location of the high voltage components in the vehicle itself, as well as the voltage of the individual cell. So from there, you will be able to know which cell is faulty. Now, other things as part of the servicing is that you need to clean all these terminals, the cells terminal, and you do not use spray. You cannot use WD-40 because it has conductivity. It is able to conduct electricity. So what we would suggest is to clean all this via sandpaper and then brush it off, and then you can actually air blow it and make sure that no dirt forms around on these grooves. Now, over a period of time, electricity, they produce heat, and this will result in residual forming on all these terminals. So once there is a residue, What happens is that the current will feel resistance when passing through. And as more residue builds up, the resistance gets higher. And we know that higher electricity gives more heat. So potentially, you're going to have an overload, or the temperature of this battery is going to go up to a beyond its normal operating temperature. So it is vital that you remove the battery, or when you're servicing a battery, you clean all those terminals and blow dry it, but do not use any spray material like WD-40 because it is able to conduct electricity. Also, there is a bus bar connecting all these volts, or rather all these cells, to form the battery pack, and that gives the total volt of the battery pack itself. The bus bar, you will also find residue, and it is part of the work that you need to do to actually, when you actually service a high voltage battery. So that is for cell testing of to ensure that there's no current imbalance, because the current imbalance will affect the mileage of the vehicle, and it will also possibly cause overheating or overloading, which may result in fire or explosion.